Anyway, yesterday I did go over this.
I know where you live. You live like 5 minutes from my house.
That is true. Okay, I went over this yesterday, but I'm going to go over it again, okay? Functions. Each x can only yield or give us one y. Okay, so again, like I said, it's like a machine, right? If I put in a number for x, I can't get more than one number out of the machine. And that's when I have a function. So no two ordered pairs can have the same first coordinate and a different second coordinate. We went over that yesterday. These examples, I want to go over them again. Remember, when we're trying to determine a function, we look at the x's, and if there's more than one arrow on any x, it's not a function. Here I only have one arrow on each x, so it is. Here I only have one arrow on each x, so it is. Looking at different examples, remember we looked at this one and each one only had one arrow, so that's a function, yes? If I look at this, I have 4, -5, 0, and 8, so I have no repeating x's. So it is a function. Here I have -1, 8, -1. So I have that repeating x. Okay, but when they have two different y's, that makes it not a function. Okay, and another way you can do this, if it's better for you visually, we can draw an oval for the domain and an oval for the range and start listing the x's. I have -1, 8, -1, I don't repeat it, and then -3. And then my range, I have 6, 9, 4, and 10. And then I can draw my arrows. -1 goes with 6, 8 goes with 9, -1 goes with 4, and -3 goes with 10. And then you can see that there's two arrows on this -1. So if looking at the list of ordered pairs like this doesn't work for you, draw a picture like this, if that's better. To lose some people. Okay, if I have a picture, a graph, the vertical line test works like this. I take a vertical line, so a stick or a pencil, or draw it, and I move across the graph. And as I move across the graph, if that vertical line touches in more than one point, is not a function. So here I've got 2 points. These 2 blue dots are touching this vertical line, and that's why this is not a function. And then as I go to this other graph, I have 1 dot, 1 dot, 1 dot only. So since only 1 dot hits at a time, it is a function over here, but when 2 dots hit at the same time, it was not a function. All right, so I'm going to test the graph, and if I start with A, as I move across, you can see I'm touching in 2 points. And when I take the wrong thing, when I take and drag a vertical line over on B, as I move across, you can see I never touch in more than one spot at a time. And that is what makes this a function or not. Since I touch in 2 points here, not a function, and since I'm only touching at 1 point any time, it is a function. So the vertical line test is probably the easiest way to test if you have a graph, like an actual picture. Function notation is a different way to represent an equation. So if I have, I'm just going to add a blank page. If I have an equation, okay, y equals 4x squared minus 2x minus 5. I just made that up. Because it says y equals everything else, it may or may not be a function. I don't know for sure. So to check if it's a function, I would have to graph it or make a table of values plugging in x's and making sure no other y's pop out. So I would have to test it somehow. I don't know for sure if it's a function or not when it is in this form. If I use function notation, okay, f of x replaces y. Okay. And function notation can only be used for functions. Okay, so using function notation, I would have f of x is equal to 4x squared minus 2x minus 5. And because it's in function notation, it is absolutely a function. It has to be. I can't use function notation unless it is a function. So function notation, we use f and then parenthesis x, and that's read f of x, which means it is a function of x. Okay? It does not mean f times x. You'll see f of x, g of x, or h of x. The only difference between those three, traditionally, you'll see f of x. But if there's more than one function, they'll differentiate them by saying f of x, g of x, h of x, so that you know this one means this one means that other thing, and that one's that thing over there. Sort of like giving your kids 3 different names instead of naming them all Bob. Right? So that's all that means. So g of x is the same thing as f of x. It's just to differentiate between different functions. When we evaluate the function, remember I did this yesterday, but I'm going to go over it again just in case I wasn't clear enough, because that happens, believe it or not. You take whatever's here in this parenthesis. So since g of x is equal to 1/2 x minus 1, which I got right here. Okay. G of 0, I take x out and I put 0 in. So that's 1/2 of 0 minus 1. Half of 0 is 0. 0 minus 1 is -1. So that's what they want you to do when they say to evaluate the function, and they give you function notation but with a number or some other letters in here. Take out the x and put in whatever is inside the parentheses. So g of 2, we'll go with purple because I feel like it. Since g of x, again, is still 1/2 x minus 1, g of 2 is half of 2 minus 1. So half of 2 is 1, and 1 minus 1 is 0. So g of 0 is -1, g of 2 is 0. Hot pink. G of 4, we keep going back to the same original function. Take the x out, put the 4 in. So half of 4 minus 1, half of 4 is 2, and 2 minus 1 is 1. I'm kind of in a color palette, so I should stay in it. Periwinkle. Can you guys see that enough? Yeah. Okay. So half of x minus 1, so g of negative 2 is half of negative 2 minus 1. Half of negative 2 is negative 1 minus 1 is negative 2. All right, with these, it's going to be the same idea. We're going to plug in what they tell us to plug in and simplify. But I have two functions now. I have f of x and g of x. Okay, so for a, they want me to do f of t, so I'm going to use f of x. And that is x squared minus 2x. But because they want f of t, I take out x and I put t in. And I can't simplify, so that one's done. Okay, for b, we're using g. So I'm going to use g of x. And that's 3x plus 5. And they want me to do g of w plus 4. So I take x out, and I put in w plus 4. And it's terrible w and a terrible 4, but you guys get the idea. And then I need to simplify, so I'm going to distribute that 3. So I get 3w plus 12 plus 5. No, because it's plus 5. So you're going to distribute the one that's touching the parenthesis. So it could be touching the parenthesis on the back, but it can't have anything in between. It's just touching it. There's no pluses or minuses. Good? Okay. And then 12 and 5 add up together to make 17. Okay, C, we're back to f. So again, f of x is equal to x squared minus 2x. Now they want us to plug in negative t. So that's negative t squared minus 2 times negative t. These parentheses are important because I'm squaring the negative t. The whole thing needs to be squared. So it's negative t times negative t, and a negative times a negative is a positive. And then I have negative 2 times negative t, so that is also positive. So when you plug in a negative for a variable that has an exponent on it, that negative needs to go in parentheses. So like if I were to plug in negative 5, it would be negative 5 in parentheses. Okay, so be really careful of that. Sometimes we're going to do evaluation, but without having to plug in the numbers. We can do it from a graph. So I have this graph of h of x. To find h of negative 1, remember that this is the x value. So I find negative 1 on the x-axis, and then look for the y value. So at negative 1, my y value is 2. That's the y value. At h of 2, I go over to 2, and I come up, and my y value is 1. H of 5, go over to 5, and my y value is -1. Then we can go the other way. For what value of x is h of x 3? H of x, remember, is y, essentially. So when y is 3, x is -4. And when h of x is 0, so when y is 0, I have two answers. -3 and +4. Okay, so you don't have to calculate anything, but you do have to know when you're looking at the y-axis and when you're looking at the x-axis. So the h of x altogether is the y, and then whatever's inside the parenthesis is the x. Finding f of 0, so that's when x is 0. We're up here at 3. F of -2, so I go back to -2, and I'm at 1. And then f of 5, it's -2. For what values of x is y 0? F of x 0, so -4 and 3. And then for what values of x is f of x -4? So when y is -4, x is -5. So 5. Yeah. Not too bad? Alrighty.
Wait. I gotta take a picture of this.
The domain of a function is the same as the domain of a relation. These are the x values. But function domains can be limited because what is that in the middle there that I got rid of? Okay, never mind, I don't know. All right. If we have a fraction with variables in the denominator, we can't have any x's that make that 0. Right? Because we can't have a 0 in the denominator. So that will limit our domain if there's any x's that will make a denominator 0. And we can't have any values of x that make a square root negative. Meaning, so here we can't have 0 in the denominator, and here we can't have negative square roots. So no negative numbers under a square root, no zeros in the denominator. So when we're looking at our domain of our function, we have to determine, are there any x's that would make either of these situations that are not allowed happen? If there are, they're not part of our domain.
Is that a negative?
Yeah, that's a negative. No negatives under square roots because we are in the real number system and not the complex number system. Okay, so we want to write the domain of this function in interval notation, and I have denominators. So the first step is to find the values that make the denominator equal to 0. I will show you. And then the second step is to exclude those, and I will show you how to do that as well. If there's a negative under a square root, we're on denominators right now. Okay, so we can't have this to equal 0. So what we do is we set it equal to 0 and find the x that would make it 0. Okay, so add 1 to both sides, and 2x is equal to 1. Divide by 2, and x is equal to 1/2. So what we know is that when x is 1/2, the denominator is 0.
Where'd you get the x plus 7 from? Why is it better?
I'm only looking at the denominator. That's all I care about is the denominator. Okay, because numerators don't limit the domain. It's only the denominator and only because you can't have 0.
So you don't have to worry about the numerator?
You just ignore the numerator completely.
Trying to get you done.
Then we exclude those values. So to write this domain in interval notation, I can go from -infinity up to 1/2, but I can't include 1/2. And then from there, I go from 1/2, which I'm also not including, to infinity. And that is my domain. This notation right here excludes 1/2. So basically I'm saying that x can be any number in existence except 1/2. And the reason it can't be 1/2 is because 1/2 is what would make that denominator 0. Okay, for b, our denominator is x squared plus 9. So we're going to set that equal to 0. Okay. Which would mean that x squared would equal -9. Everybody so far following me? Which means there's no solution to that, right? There's nothing I can square it and it gives me a negative. You guys all agree? Okay. Since there's no solution to this, that means that there are no x's excluded.
All my X's are excluded.
Because we're not having to exclude any x's because there's no way to get a 0 in the denominator, my domain is going to go from -infinity to infinity. There's no way to make this equal 0 because there's no way that x squared can equal a -9. Okay. And since there's nothing excluded, the domain can be every number. So it goes from -infinity to infinity. We don't have any limitations. With the square roots, our first step is going to be to find the values that give us a negative under the square root. And then the second step will be to exclude those. Because we can't have any negatives under the square root because we're still in the real number system. So for C, I take what's underneath the square root. Okay. And negatives occur when I'm less than 0. Does everybody agree with me? Negatives happen less than 0? Okay. So I'm going to solve this inequality. So I'm going to subtract 4 from both sides. And when t is less than -4, then I don't have to flip it because I didn't divide by a negative. It takes time. But when t is less than -4, this square root would be a negative. So I can't have that. So this is my lowest possible t. So my domain goes from, includes -4, because that gives me a 0, and then it goes up to infinity. Because -4 is the smallest possible number. I'm allowed to be 0. I just can't be less than 0. Okay, when we get D, an example like D, there are no square roots. There are no denominators. So there are no limits. So my domain is -infinity to infinity. The only thing that will limit a domain, the only thing that will limit the x's that you can plug in, is a 0 in the denominator, so having a denominator, or having a square root, because you could end up with a negative. So if you look at D, I have t squared minus 3t. I don't have any denominators. I don't have any square roots, so I have no limits. So it's everything, -infinity to infinity.